Okay, so I'm going to go back up because my video went out. Today we're talking about we're talking about angles and their relationships. We know that an angle is made from two rays and a vertex.
You know what I was told? I gotta get in here.
What?
I said at 10:30 I'm giving grace. Those people for 136 and they all dropped to come to I thought it was so funny.
Okay, so yes, are we all? Oh, I better. So I had the students create their own X's to show the relationship. I'm just doing the recording, so I'm not talking to myself, I swear. And we found that when you add X and Y together, they should add up to 180. And that the ones that are vertical, meaning across from each other or opposite, have to equal each other. Did you need one of these? Is that what you're looking for? I'm so sorry. Oh, there's... Okay. So, recap from just us going to break. We have adjacent angles, right? They share common side and a common vertex. Then we have supplementary angles. Supplementary angles have to add up to 180. And sometimes we call them linear pairs if together they make a straight line. Then we talked about complementary angles, right? Where angles that add up, whose sum is 90 degrees. So, like if angle 1 was 40, angle 2 would be 50. What happens if angle 1 was 30? What would angle 2 be? 60. If I come back to supplementary, if this was 120, no, A would be 120, that's your obtuse angle. If A was 120, what would B have to be? 60. Because together they make a straight line that has to add up to 180. See how it all, isn't math beautiful? It all comes together. It is, it's beautiful. So we did our X's and we found that the vertical angles, the ones that are across from each other, were always the same. Did we all figure that out? I know some of us, we had to readjust our protractors because there's two numbers on there. And what happened when we added the ones that were adjacent next to each other? What they had to equal 180. So I did not lie to you, right? These are actually, you can actually check these out on your own. So right here, they want us to label the relationships, and some of these may have more than one label. So what could I label A and B as? What do these represent from those words we talked about? Adjacent, complementary, vertical, supplementary. What would these two be? Those are adjacent. No, they aren't adjacent. Who told me adjacent? They're vertical. Adjacent would be if they were next to each other, right? What are they again? Vertical. I'm also going to throw another word out there that we didn't talk about. We talked about the other day. They will always be congruent. What does congruent mean? Same size, same shape. These two angles will have the same measure. So vertical and congruent. All vertical angles are congruent. What about these? What would I call these? Yeah, complementary. I can think of two more. What's another word I could use? Adjacent. Very nice. One more. Let's see how much I can stretch your mind. There. Well, it would be a right angle if it had the box. I drew the box, but you're on the right track. What are 60 and 30 called? No, 60 degrees by itself is what? 60 degrees is acute, and 30 degrees is acute. You are correct that together it would be right. We good? So in a way, you were correct. It is a right angle, but I was going with this is acute, and the whole thing is right. We good? Okay, so let's look at this one. What kind of words can we use for this one? Supplementary. Good. Linear pair. Very nice. Any others?
This one would be acute.
This one would be acute. And what would be the 120? Obtuse. Any other things? They're adjacent. There we go. We got a lot of words. Supplementary, linear pair. They're adjacent because they share a vertex and a common side. One is acute and one is obtuse. Excellent work. Okay, so now we're going to do the math. We love math. Math is fun, right? Yay. Okay, what's angle B? 30. Because I have a right angle here, B plus 60 has to equal 90. So B has to equal 30. Now, if you just put B equals 30, I'd be fine. But I'm a math teacher, so I have to write the top one, right? What? Where? Oh, okay. I'll make it look like a degree. Oh. Peter always has to keep me on my toes. Is that better? Okay. Okay. It's not as easy to write with these pens as what you think it is. It really isn't. Just ask, yeah. Okay, what would I do for this one? Yes, B plus 124 has to equal 180. So to solve for B, we would subtract it from 180. So B would equal a little degree there. Do I have to do any math for this one? No. What's B? This is just 44. We like those. It makes our life easier when I could just look at it and go, oh, it's just 44. No work. Because what are these called again? What is this? Vertical angles. And vertical angles are always congruent. Uh-oh. Huh. Any ideas? You are a genius. Why do I know 6x plus 3 has to equal 81? What are these called again? They're congruent because they are vertical angles. All they did was try to mess with your brain and they just connected the outer ones. It's still a big X, right? This is still just a big X. And they're saying this is 6x plus 3 and this is 81. All they did is connected. That's all they did. So these two have to be equal to each other. So if I'm going to solve for x, it's just a two-step equation. You subtract 3, which is what, 78? And then divide by 6. X is equal to 13. Okay. Now, are these going to be equal? Everybody say no. No, because I can just look at it. This is an obtuse angle. This is an acute angle. There's no way those two are equal. Just by looking at it, you should be able to say, they're not equal. But what relationship do they have because they make this straight line? They have to equal 180 when added together. This is a linear pair because they make this straight line right here, right? So 2x plus 17 plus 123 has to equal 180. So then we have 2x plus, what's 123 plus 17? 140 is equal to 180. You subtract 140, get 2x is equal to 40, and x is equal to 20. We could check our answer if we wanted to by plugging this in and then making sure both angles added up to 180. Anybody confused on why this one I set up to 180, but this one I set equal to each other? Do we understand what the difference is? These are vertical angles. They're across from each other, right? These, yes, go ahead.
Sorry. So we couldn't just do 180 take away 123 for the other one.
Well, you could, but it wouldn't give you what they asked for, which is x. Now, what I would have done, though, Miranda, is if I wanted to check my answer, I could substitute 20 in, do the work, and it should equal what you got if you subtracted it from 180, right? Does that make sense?
Yeah.
Okay. Okay, over here. So what do I do with these two now? I'm going to add them. Is it 180? No, it's 90 because of this box here. Remember your brain, every time it sees the box, what number we think of? 90. So these should add up to 90. Well, we don't know. I need a plus. We don't know if they cut it in half. We just have to do this because it could be cut in many different ways. Oh, you said 45, and I was about ready to write 45. So we combine our like terms, right? What's 4x plus 3x? 7x. 2 plus 4? 6 equals 90. We're going to subtract 6. 7x is equal to 84. Divide by 7. What does x equal? 12. So this one we set equal to 90 because of the box. This one we set equal to 180 because it made a straight line and they were adjacent. This one set equal to each other because they were vertical angles. They were opposite of each other, right? They were across from each other. They were not adjacent. Yay?
Yeah.
Okay. Oh, boy, that one looks funky. Any ideas? You are right. He is so talented. If I connected this, what shape do you see here? A full circle, right? And a full circle has to be 360 degrees. Does everybody understand that a full circle is 360? So you add all three together and set it equal to 360. So x minus 75 plus 39 plus 297 is equal to what? 360. Because it made a full circle if I connected it. You need to combine your like terms. Be careful because this is a negative 75. Where's my mouse? Did it fall? Oh, that's right here. So I'm going to do negative 75 plus 39.
76.
Thank you. I owe you a sucker. Plus 297 has to equal 261. So I have x plus 261 equals 360. And now I'm going to just subtract the 261. So what does it equal? 99. This is called angle addition postulate. Does anybody remember what postulate means? Does anybody remember what postulate means from the very first day of school? A postulate is an accepted truth. I don't have to prove it. And angle addition postulate states that if I add this angle and then I add this angle, it will equal the whole angle. Does that make sense to everybody? So, like if this was 20 degrees and this was 80 degrees, 20 plus 80 would be 100, would be the whole angle measure, right? Okay, but that's not what's here. It says angle, the measure of angle UVY. Use your finger and mark. I have so many students that mismark their angles, and I'm like, use your finger. Give the angle your finger. UVY is 24. Now I go over here. YVW 18x plus 2. UVW is the whole angle, and that's 21x plus 8. So how do I set this one up then? Yes, I add these two little ones together, set it equal here. 18x plus 2 plus 24 has to equal 21x plus 8. Right? Okay. Well, combine your like terms. 18x plus 26 is equal to 21x plus 8. I need to subtract x to get it all on one side. So I subtract 18x. I get 26 is equal to 3x plus 8. I subtract 8. I get 18 equals 3x. I divide by 3. X is equal to 6. Now, always re-look because it gets tricky. What did the question ask? Find x. So I did. Now, sometimes it may ask find angle UVW. And then you'd have to substitute it back in. always look to make sure you answered the question. We did for this one, but they could trick you. Okay, so just as a review, what are acute angles? Acute, less than 90. Obtuse, yeah, greater than 90. Yep. I can't write that fast. Less than. Right angle?
Exactly 90.
Yep. 90 degrees. How much does straight angles add up to? 180. Adjacent angle. Share a common vertex and side. Complementary.
The sum is 90.
Yep, sum is 90. Supplementary?
Add up to 180.
Yep, sum is 180. Linear pair, same thing. Yep, sum is 180. What about vertical angles? They're the same. Vertical angles are congruent and they're opposite. Yep. Congruent. I'll just draw a picture. Pictures. Say everything. Those would be, and they're congruent. Big thing you have to remember is they are always equal or congruent. Okay, so we did not get, I may have time, I don't know. I printed out a worksheet, but it also included parallel lines and transversals. So I'm going to pick up parallel lines and transversals maybe tomorrow, or depends how fast you get through these other ones. So I'm only going to have you do a certain amount on the worksheet, and then you stop. And then we'll figure out what we're going to do from there, okay? Is that fair? Second PowerPoint, some of you went ahead, which is okay. This one. Okay, so this is past 11. And we are going to go over the parallel lines and transversal vocabulary and relationships. We're skipping the exploration because we did a lot and I'm looking at the time. I want to make sure I can get through this. Maybe I'll do that as my do now tomorrow. Okay, parallel lines are two lines that are always the same distance apart and never touch. Parallel lines have the same slope. In formulas, parallel lines are indicated with a pair of vertical pipes like this, which we talked about before. I want you to underline that they have the same slope. We will be using that when we do coordinate geometry proofs. We need to remember that parallel lines have the same slope. Okay? And some of you had me for Algebra 1A. I'd be sad if you forgot that. Transversal. Transversal, we talked about a transversal earlier today. It's a line that intersects two lines. Normally, when we're talking about transversals, we think of them being parallel. But you could have a transversal that's not parallel. But this would be the transversal because it intersects both of these lines here. Does that make sense? Okay. Now, alternate interior. When you think of the interior of your house, is that on the inside or the outside? Inside. Notice, when I have parallel lines and I cut a transversal, I have 8 sets of angles, right? 1, 2, 3, 4, 5, 6, 7, 8. These are the inside. So 1, 4, 5, and 8 are inside, so they are interior. Alternate means they cross over the transversal, and one is up and one is down. So 4 and 8 are alternate interior angles. They also are considered congruent. If I measured them, they would be congruent, which means that these two angles would have the exact same measures. So if this was 40 degrees, what would this over here be? 40. Okay, so now could you name me, there is one other pair of alternate interior angles in this picture. What's the other pair? 1 and 5. So angle 1 would be congruent with angle 5, and they are alternate interior angles. They are on the inside. One is up and one is up and one is down, and they're on the opposite side of that transversal. And they will always be congruent. So, exterior is the outside of your house, right? Okay. The alternate exterior angles would be 7, 6, 2, and 3. The alternate would be 1 is up and down from each other and on the opposite side of the transversal. So angle 2 and angle 6 are alternate exteriors, and they are also congruent. What's one other pair of alternate exterior angles? 3 and 7. So angle 3 is going to also be congruent to angle 7. And those are called alternate exterior angles. Corresponding angles. Corresponding angles are angles in the same position. I think of it like if I were to cut and lay the sets of 4 angles on top of each other, that the ones in the same position are corresponding. So, do you see here how this is upper left? And if I'm looking at these 4, this would be considered upper left. Angle 1 and angle 5 are corresponding angles. There are many more corresponding angles. There's 3 sets more. What angle is a corresponding angle to angle 2? Uh-oh. This one, here's 2. Up. This one's up. This one would be up. It would be 6. And corresponding angles are also congruent. If I looked at angle 2, this is an acute angle. Remember how we talked about acute angles today? But if I looked at angle 8 is an obtuse angle. There's no way that 8 is equal to 2, correct? So the corresponding angle to 2 is actually angle 6. Because this is upper right, this would be upper right. What's the corresponding angle to angle 7? Angle 3. Because right here, this one is lower left, and so this one is lower left. So angle 3. Yeah, I know angle 7 is congruent to angle 7. Okay, and I have one more set. Angle 4 corresponds to what one? It corresponds to angle 8. And all corresponding angles are congruent. There's 4 pairs of them, and they would all be congruent. Vertical angles. Did we talk about vertical angles today?
Yes.
Yes, and there are 4 pairs of vertical angles. And vertical angles are always what? Congruent. So angle 1 is congruent to angle 4. What about angle 2? What's it congruent to? What is it vertical to? Angle 2 is vertical to angle 3. Yeah, I'm talking about vertical. I'm sorry. You are correct that angle 2 is congruent to angle 7 because those are alternate exteriors. But for vertical, since we're on the vertical slide, angle 2 is vertical to angle 3, right? So which one is vertical to angle 5? Yep. And which one is vertical to angle 6? Very good. Now, these are the only ones that we do, well, unless they were adjacent to each other, but for the pairs that we have talked about on the slides, these are the ones that are supplementary. They are not congruent, and those are called consecutive interior angles. Or sometimes you'll hear me say same side interior angles. Same side interior or consecutive interior, same name, a different name, same angles. It's just different geometry books, call them different names. I wanted you to be aware of both, right? So, and plus I sometimes will say consecutive and sometimes will say same side. So you have to realize that these two mean the same thing. So angle 3 and angle 5 have to have a sum of 180 degrees. What other pair of angles would be considered consecutive interiors or same side? Yep, angle 4 plus angle 6 would equal 180. And technically I should have a little m in front of there for a measure of. Okay. Am I going too fast? No, okay. So, the relationships. Corresponding angles are congruent. Alternate exterior angles are congruent. Alternate interior angles are congruent. Vertical angles are consecutive interior angles, supplementary. Don't say congruent. Very good. And what's great about that is if you know one angle, you can find them all. So let's say angle 1 is 125 degrees. That would mean angle 4 is also 125 degrees because those are vertical angles. The corresponding angles to these would also be 125. So this would be 125. This would also be 125. How would I find the measure of the other angles? Yep, 180 minus 125 is what answer? 55. So that's 55. And all the other angles now are 55. So that's 55. This is 55. This is 55. And this is 55. Not too bad, is it? So if angle 1's 140, go ahead and figure out what the other 7 angles would be. So did you get them all? Okay, so did you have 140, 140, 140, 140, and then the other ones are what? 40. I'm going to change the color. Why isn't it letting me change the color? Come on. It's not letting me. 40, 40, 40, and 40. Okay, so now we're going to go to this one is, I'm going to skip this one because I think you know those. Let's look at a couple. I'm just looking at time. So we're jumping to question 4. What would I do with these two to solve for x? Yes, because these, and what are they called? What are these ones called? They're angles, but they have a specific name. Alternate. Alternate. Exterior. Exterior, because they're on the outside. Outside angles. And so these would be 7x minus 20 equals 4x plus 16. Now, you all took pre-algebra. You all took Algebra 1A. You all took Algebra 1B. I'm not going to solve those because you should be able to solve them, okay? I'm just going to help you set them up because that's the geometry part. So let's go to the next one. Are these going to be congruent or supplementary? Congruent. What name is it? Does anybody know the name? These are corresponding. We know they're corresponding because they are in the same position. Upper left, upper left. If you think about these being 4 and these being 4, they are in the same position. So these we would set equal to each other. And then you would work it out to find x. Right? Okay, I'm going to move to the next one because those who have children in the YLCC, I never want to make them late. Okay, over here, what are these called? These are corresponding again. So you would just set them equal to each other. Now, I will say, because some students get confused, yes, always your angle measures are going to be positive numbers, but sometimes you can get a variable of x being negative because when you substitute it into the angle, you still get a positive angle. So don't get too concerned. I don't know if this one is. I think this one would be positive. But don't get too concerned if you end up getting a negative x. It's just the angles won't be negative. Until you get into trigonometry. Then you can have negative angle measures. Okay. What is this one? Now, this one's different. Nope. They are interior. They're going to be supplementary because these are same side or, same side or consecutive interiors. Side interior or consecutive interior. However way you want to say that. It means the same thing. But they are supplementary. To solve this one, you would have to take 2x plus 3x plus 20 and set that equal to 180. Now, the other thing is, it didn't only ask for x. What else did it ask for? Find the measure. So for this one, you would have to do 3 things. You would solve for x. You would substitute in for this angle, find this measure, and you'd substitute in to find this measure, right? Okay. And then, is that? Let's do these together because this is where you're struggling. I think you guys have the math down. It's the naming that you don't have down. So what is this one? Is it corresponding, consecutive, alternate, interior, alternate, exterior? It's consecutive interior. They're not alternate. Alternate would be up and down. This one's consecutive interior. What about this one? These are vertical. Because vertical angles are opposite of each other, right? What about this one? Is it inside or outside? Outside. Because see, they're on the outside. Inside would be here. Right? This one. Corresponding. Because they are the same position. Upper left, upper left. What about number 5? Corresponding again. What about number 6? No, they're outside. Alternate exterior because they are on the outside. They're up and down from there and they're on the outside. Interior would have been here and here or here and here. Well, yeah, number 7 is alternate interior. And what would I call number 8 again? See, that's vertical. Oh, I have 2 more and then we're done. What are these? Consecutive interior. This would be supplementary, right? What's this one? Corresponding. Boy, we learned a lot today. Tomorrow, I'll review. Tomorrow, I'll review. Is that good? Okay.